Hello grade 3s, I hope you're doing well. Okay, as I was marking your work, I found out that some people are still having challenges in how to multiply. How can we multiply 1 times 3, or how can I get the answer for 3 times 4, or the answer for maybe 5 times 7. So here are the different methods I'm going to guide you with. Of course, I know you have watched the videos and still people are still struggling. So I want to add a voice to the videos that you've been watching, and I'm going to start with these different methods. Then we shall also do corrections for the long division that I gave you. So looking at these numbers, we have the first method. The first method is that one whereby we keep on adding numbers. For example, if I'm asked to get 4 times 3, this is the same as telling me to get 4 added 3 times. What is the answer? Or it's the same as asking me to get 3 added 4 times. What is the answer? So that is one of the methods. So if I'm asked to get 4 times 3, this is the same as having 4 plus 4 plus 4 3 times. So what is 4 plus 4? 4 plus 4 is 8. So 8 plus 4, you get 12. Or you can use adding 3 4 times. That is, I have 3 plus 3 plus 3 plus 3. So if I add 3 plus 3, that is 6. Then 6 plus 3, you have 9. And then 9 plus 3, you'll have 12. So either you can add 4 3 times, or you can add 3 4 times, and the answer will still be the same. This one, you've also seen it in the videos. At the same time, it is also there in your textbook. Then we also have 7 times 5. Can either have 7 added 5 times, or have 5 added 7 times. Whichever you feel is comfortable for you or easy for you is what you use. So you don't have to use both methods. Either you add 7. When I say either, it means that you have the option of adding 7 5 times, or you have the option of just adding 5 7 times. So usually we find it easy if we have 7 times 5. Look at the big number in this problem, which is 7. So since 7 is the big number, it means that it is better that I get the big number and add it the number of times which is small. So the number of times here is 5. So if I get 7 and add it 7 times, I'll get the same answer as getting 5 added 5 times. But then you find that even adding 5s is an easier way than adding 7. So whichever you feel easy is what you go with. You find that adding 4s is easier than adding 3s, so you add 3s 4 times. If you find that adding 5s is easier than adding 7, so you add 5 7 times. So if you start with adding 7 5 times, you have 7 plus 7, we get 14. 14 plus 7, you get 21. Then 21 plus 7, you get 28. 28 plus 7, you get 35. And then it is so easy adding 5s, but then it has to be 7 times because you've decided to use 5. So 5 plus 5 is 10, plus 5 is 15, plus 5 is 20, plus 5 is 25, plus 5 is 30, and then 30 plus 5 is 35. Then even 2 times 8, you find that adding 2s might be easier than adding 8. But then if I have 2 times 8, it means that I'm going to get 8 and add it 2 times. Or it means that I'll have 2s and add them 8 times. So if it is 8 plus 8, this is very short. You get 16. But then having the 2s 8 times, it may be long, but then you find that adding 2s can be easier than adding 8s. So we have 2 plus 2, which is 4, plus 2 6, plus 2 8, plus 2 10, plus 2 12, plus 2 14, and then plus 2 we have 16. Then we have a note here that all multiples or products of 2s end with an even number. So we have a new word which is multiples, and then we also have another new word which is even numbers. What do we understand by the word multiples? Now in these videos, you never had any of the videos having multiples. Why? I have a video on multiples, but then it is one that is hoping people who are like for grade 4s who are learning about factors and multiples. But then for us here, we are just learning how to multiply. But still, we need this word to help us in the second method, in the other last method that I have given, because we have actually about 3 methods that can guide us in multiplying. One of the methods is adding. If they ask us 3 times 4, it means I can add 3 4 times, or I can add 4 3 times and get the answer. If I'm asked to get maybe, let me see, 3 times maybe 8, it means I can add 3 8 times, or I can add 8 3 times. Whichever you feel is comfortable is what you go with. That's a method. And in these methods, we are avoiding to cram, just guessing now what would be the answer. But you're working out so that you can get to the answer. And these are the first things that we need to know. Because when I get the multiplication table, as long as even if I'm trying to master it, there is an element of cramming that I have to, because you have to keep on practicing this every single day until when it sticks in your head, and then you can tell from out of the blue. If they ask you what is 4 times 4, you'll be able to say 16. What is maybe 3 times 9, you'll be able to say it is 27, because you have been practicing these multiplication tables by looking at them and sticking in your head. That will be method 2. But before we go to method 2, we need to know what a multiple is. So when you look at this, I've said that multiples, these are products got after multiplying numbers. If I have 2 numbers, say 2 times 3, the answer I get is a 6. But then this 6 is a product of multiplying 2 and 3. So the other word we need to know is product. Product is the answer we get after multiplying. But still, we can even say multiple is a product of numbers. So when I say 2 times 3 and I get my answer 6, 6 is a product of 2 times 3. At the same time, here in the note we are saying, in this example above, 6 is a multiple of 2. 6 is a multiple of 2. We are saying that when I get a number and I multiply it with a number, the answer I get is a multiple of these 2 numbers. So we can say that 2 is a multiple of, you can say 6 is a multiple of 2. At the same time, we can also say that 6 is a multiple of 3. Whereas when I say 2 times 3, I get the answer 6. I can say 6 is a product of 2 and 3. But then when I'm talking about multiple, I'm now talking about a single number. That 6 is a multiple of 2, or 6 is a multiple of 3. The other way of defining a multiple is a number that divides another number without leaving a remainder. When you look at this other note, I have said that 6 divided by 2 is 3. There is no remainder. So whenever we divide a number and we have no remainder, it means that that big number that we have used to divide the small number is always a multiple of the small number. Or when we have a dividend, 6 is standing for a dividend, and then 2 is standing for a divisor. So whenever I have a dividend divided by a divisor and the answer has no remainder, it means that the dividend is a multiple of the divisor. So 6, we have looked at dividends and divisors in our videos, and I hope you understood what they are. So when I get 6 and divide by 2 and I get 3 with no remainder, it simply tells me that 6 is a multiple of these 2. At the same time, I can have 6 divided by 3 and I get the answer as 2. There is no remainder. So I can conclude that 6 is a multiple of this 3. The dividend is a multiple of the divisor because the answer has got no remainder. The answer is the quotient. Whenever we have a dividend divided by a divisor and the quotient, there is no remainder, it means that the dividend is a multiple of the divisor. So 6 is a multiple of 3 because in our answer we have no remainder. Then we have what we call even numbers. I already noted here and I said we are looking at 2 new words, multiples and even numbers. But I think you have learnt about even numbers even when you are still in grade 2. Okay, this is a reminder to those who have forgotten. Even numbers, these are numbers that give no remainder when divided by 2. We always consider a 2 to help us know what an even number is. The opposite is odd number. I haven't written it down here, but we can say briefly about it after talking about the even numbers. These are numbers that give no remainder when divided by 2. Those are even numbers. What are some of the even numbers? Examples of even numbers. We have 2 divided by 2. Since we have to divide by 2 and we have 1, there is no remainder. It means that this 2, which is the dividend, is an even number. Then we have 4 divided by 2. The answer is 2. There is no remainder. It means that this dividend, which is dividing 2, is the even number. Then we have 6 divided by 2. It's equal to 3. There is no remainder. It means that this 6 is an even number. We have 8 divided by 2 equal to 4, no remainder. It means that this 8 is an even number. Then we also have 0 divided by 2. Any number, 0 divided by any number, it is always 0. So 0 divided by 2 is 0, so there is no remainder, meaning that 0 is also an even number. So we make a conclusion and we say that all numbers that end in 0, 2, 4, 6, and 8 are first of all multiples of 2, and at the same time they are even numbers. Because here, somewhere we noted that all multiples or products of 2's end with an even number. So whenever we have a number that ends in 0, 2, 4, 6, and 8, we say that that is a multiple of 2. At the same time, we can say that that is an even number. However much I have 5, but then it ends in 0, that is 50. This one will be an even number. At the same time, it will be a multiple of 2. If I have 7 and 2, 7 is ending with a 2, making us have a number 72. 72 is ending in a 2, making us see this as a multiple of 2. At the same time, it is an even number. The opposites of even numbers are odd numbers. Odd numbers, now these are numbers when we divide by 2, they give a remainder, and the remainder is always equal to 1. The remainder should be 1. When the remainder is not 1, then those ones we are not calling them. For us, we know that odd numbers, these are numbers that when we divide by 2, they give us a remainder which is equal to 1. An example, look at how I've selected my even numbers. They've been 0, 2, we have 4, we have 6, we have 8. So what are the gaps missing? We have from 0 to 2 there is 1 missing, 2 to 3 there is 2 to 4 there is 3 missing, 4 to 5 or 6 there is 5 missing, and then 6 to 8 there is 7 missing. So the opposites of even numbers are odd numbers. Any numbers that end in these ones are always called odd numbers, because when we divide by 2 we shall get a remainder which is equal to 1. An example, we can have a 21. Even if 2 is an even number, but the number here now is 21 and it's ending in 1. Since it's ending in 1, which is an odd number, it means that this one will automatically, when we divide by 2, it will give us a remainder which is equal to 1. So 21 is an odd number. We have another method of how we can learn how to multiply. We can use the multiplication times tables. Here it means a learner must practice their multiplication times tables and master them such that they are at their fingertips. When I say fingertips, it means that when I ask you what is 4 times 5, you're able to directly tell me that it is 20. What is 3 times 8? you're able to tell me that it is 24. You have mastered these things are in your head and they're at your fingertips. You can easily say them out aloud. So we have an example of a times table which is from 2 to 5. We have started with small numbers. We haven't yet gone to the 6 up to 10 or 9. But then here we are basically looking at multiplication tables of 2 to 5. We have 1 times 2. 1 times 2 is 2. 2 times 2 is 4. 3 times 2 is 6. 4 times 2 is 8. 5 times 2 is 10. 6 times 2 is 12. And so on and so forth until when we reach 12 times 2, which is 24. But you have to notice that there is some pattern that is going on here, moving from one number to another. To move from 2 to 4, what do? We've added a 2. From 4 to 6, we've added a 2. From 6 to 8, we've added a 2. From 8 to 10, we've added a 2. From 10 to 12, we've added a 2. 12 to 14, a 2. Like that. That is a pattern in the multiplication times table of 2. Look at the multiplication times table of 3. 1 times 3 is 3, 2 times 3 is 6, 3 times 3 is 9, 4 times 3 is 12. Like we are multiplying with 3's here, numbers from 1 to 12. And at the end, 12 times 3 is 36. But still, you can look at the pattern. To move from 3, the first answer when you are multiplying by 1, we have 3. The next one is 6. The next one is 9. The next one is 12. What is happening? From 3 to 6, we are adding a 3. From 6 to 9, we are adding a 3. From 9 to 12, we are adding a 3. From 12 to 15, we are adding a 3. 15 to 18, a 3, and so on and so forth. Same applies to that of 1 times 4, 2 times 4. That is the times table for 4. You find that the first answer is 4, the next one is 8, the next one is 12. But still, to move from one to another, we keep on adding 4's until when we reach the last one, which is 12 times 4, which is 48. Same applies to 5. Now, the 5 times table is very easy. And I'm sure everyone knows that from 5 plus 5 is 10, plus 5, 15, plus 5, 20, like that, until when we lastly go to 12 times 5, which gives us a 60. So now you have to keep on practicing this. I expect you to draw these timetables in your books. And please, every morning, the first thing you do is look at them. You can decide to first of all look at the times table for 2. The first maybe 2 days and master that one. Go to 3 for maybe 2 days. Master it. Go to 4, you can use maybe 3 days every morning. Before we start our lessons begin at 9. So that is from, if you've woken up at 7, you've prepared yourself at 8. You're done with your breakfast, or you're done with your breakfast at 8:30. Those 30 minutes can be good enough before you start your lesson, and master the times tables. You can decide to start with 2, 3, 4. You can use 3 days, and then 5 times tables is not a very difficult one. This one is easy. You can even have 2 or 1 day, and then you'll be able to master. Some of you have even already mastered the 5 times tables. Then the last method is that one of using the method of listing multiples using certain patterns or sequences. And that is what I've been trying to say when I was trying to talk about the times tables for 2, 3, 4, and 5. I was saying when we list multiples, we already said these are products of a number, or these are numbers that when we divide by that number, they'll give us a remainder 0. So the first multiple of 2 is 2, because 2 times 1 is 2. The next one is 2 times 2, which is 4. The next one is 3 times 2, which is 6. So you see that to move from 2 to 4, we've added a 2. From 4 to 6, we've added a 2. From 6 to 8, we've added a 2. From 8 to 10, we've added a 2. 10 to 12, a 2. So that means I expect you to find the next pattern in, the next number in this pattern or sequence. You can call it a pattern or a sequence. Then we have multiples of 3's. The first one is when we have 3 times 1, which is 3. Then 3 times 2, which is 6. 3 times 3, which is 9. So you see that even here, to move from 3 to 6, it's plus 3. 6 plus 3, we get 9. 9 plus 3, we get 12. 12 plus 3, we get 15. So you just know that now this one, 3 is standing for 3 times 1. 6 is standing for 3 times 2. 9 is standing for 3 times 3. 12 is standing for 3 times 4. So when you master these and you know how to list them, 3, 6, 9, 12, 15, 18, 21, 24, then you'll be able to tell. Because when you're using your fingers and you say this is 3, that means you're having 3 times 1 because you're having the first finger. Then you have the second finger as 6, that is 3 times 2. The third finger as 9, that is 3 times 3. The fourth finger as 12, that is 4 times 3. The fifth finger as 15, that is 3 times 5, and so on and so forth with your 6th, 7th, 8th, until when you reach the 10th, you can even add on 11 and 12. So that is how we use the multiples to help us guide us in knowing the times tables. So when you have 4, you say this is 4. The first finger is 4, that is 4 times 1. The second finger, 4 times 2 is 8. The third finger is 4 times 3, which is 12. The fourth finger is 4 times 4, which is 16. Then the fifth finger is 4 times 5, which is 20, and so on and so forth. And how are we able to do that? Is that every next number we keep on adding 4s to get to the next number. This is practicing, and with practice, it makes perfect. It's just that we have just started learning more about multiplying and dividing. And once you know your multiplication, it is always easy to know the division. So the dividing, solving division equations using long division is going to be another audio that I'm going to shoot. So I'll stop at this, then I'll get another audio for the corrections to solving division equations using long division and correction. This has been me, your teacher Jackie. Have a good day.